Question 1.8. In this question, we need to find out which reaction results in the highest pH. We are given these acids and these bases. We know that when an acid and a base react, a salt and water are produced. Let's write the equations for each reaction. When nitric acid and potassium hydroxide react, the products are potassium nitrate and water. We can see the potassium ion from the base and the nitrate ion from the acid form the salt potassium nitrate, and the hydrogen from the acid and the hydroxide from the base form water. In a similar way, when hydrochloric acid and sodium hydroxide react, sodium chloride and water form. When ethanoic acid and sodium hydroxide react, sodium ethanoate and water form. But the last reaction is slightly different. Ammonia is a gas, and when it comes into contact with the water in the hydrochloric acid solution, the ammonia reacts with the water to form ammonium hydroxide, which is a weak base. Weak bases dissociate partially into their ions, and in this case ammonium ions and hydroxide ions. So we could write the equation like this. Hydrochloric acid reacts with the base ammonium hydroxide to form the salt ammonium chloride and water. All of these equations are balanced with a 1:1 mole ratio of acid to base. We know that strong acids and strong bases dissociate fully or completely in solution. In red, we have the general equations for this. Because the dissociation is complete, a strong acid produces a high concentration of hydrogen ions in water, which can react with water to form hydronium ions. These acids shown in yellow, namely nitric acid and hydrochloric acid, are strong and produce a high concentration of hydrogen ions in solution. Since strong bases dissociate fully, they produce a high concentration of hydroxide ions in solution. The bases in yellow are strong bases, namely potassium hydroxide and sodium hydroxide, and they produce a high concentration of hydroxide ions. Weak acids and weak bases dissociate only partially, forming an equilibrium with their ions. Weak acids therefore produce a low concentration of hydrogen ions, and in turn a low concentration of hydronium ions. Ethanoic acid is a weak acid and produces a low concentration of hydrogen ions in solution. Weak bases dissociate partially and produce a low concentration of hydroxide ions. Since ammonium hydroxide is a weak base, it produces a low concentration of hydroxide ions. Now that we know the equations for each acid-base titration and the relative concentrations of hydrogen ions and hydroxide ions, we can start to deduce the final pH of the reaction at equivalence point. Equivalence point is the point in a titration at which the acid and base have both been used up and neither is in excess. This happens in each of these equations when the moles of each acid and base are the same according to the 1:1 mole ratio. A strong acid and a strong base with a high concentration of hydrogen ions and a high concentration of hydroxide ions will produce a neutral pH at equivalence point. A weak acid and a strong base will result in a slightly basic pH at equivalence point, so the pH will be above 7. And a strong acid and a weak base result in a slightly acidic solution at equivalence point, and so the pH is below 7. So the pair which gives the highest pH is ethanoic acid and sodium hydroxide, which is answer D.